Dear students, today's topic is power loss in an AC circuits when there is a circuit elements, that is the resistors. We know that resistor always opposes the flow of the current. So if I apply an AC voltage across a the resistors always opposes the change of current. So this is our uh, AC circuits in which a resistor is here. Applied voltage is, suppose this is the applied voltage, E is equal to E naught sin omega t. So we know that this voltage of AC always change in directions and in magnitude. You know that magnitude is here, like this is the maximum magnitude of this voltage, and this is also maximum voltage, but in opposite directions. So here direction and voltage always changes. So obviously the resistor will oppose the change of current. Always resistor opposing the flow of the current. So here let us start how to find the power loss in a resistors. So this is our sinusoidal means this is our sinusoidal. This is sine curve or the cosine curve. Sine curve and cosine curves are oscillating curve. So they always change in direction magnitude. So it is the positive direction of this oscillation, this is the negative direction of this oscillation. So we know that power rate of doing of work, or you know power formula is P is equal to dW upon dt. So in a small time dt, power loss would be dW is equal to P dt. So this is the work done to maintain a current in this alternate circuit. And also we know that power is equal to voltage into current. So we have voltage is this one, and also we know that the current would be in the same phase as that of the alternative voltage. Therefore our current at the time of t will be I is equal to I naught sin omega t. If I place this value here, I will get the value of power. So work done to maintain a current I in the circuit would be dW is equal to P dt. Put the value of P has the value E into I dt. Now our E has the value, this is our E naught sin omega t multiplied with I naught sin omega t. Now this value becomes E naught I naught sin omega t, it would become sin square omega t. Now using the trigonometrical relations, if I multiply by 2 and divide by 2, so I have this value 2 sin square omega t. From the trigonometry this will be changed 1 minus cos 2 omega t. We know that the relation, since cos twice omega t is equal to 1 minus 2 sin square omega t. So this relations comes from this relations. So this is our work done at the time of t in the small time interval dt. So this is our work done in the time of dt. Now the average power loss, the average power dissipated per cycle. Average power dissipated per cycle will be P average is equal to work done divided by the time. In one cycle the time taken is one time period. So from here 1 upon T integration of dW. If I integrate dW, I will be able to find omega. So now after putting this value 1 upon T integration dW, it has the value this one, E naught I naught divided by 2 in bracket 1 minus cos twice omega t into dt, and the time goes from t is equal to 0 to 1 time period. It means that if this is the t equal to 0, from here to here, this is one oscillation, time taken is 1 time period. So in 1 time period, how much the work is done? Yeah, what will be the average powers which is consumed, yeah, which is expanded by this alternating voltage. Therefore, average power dissipated E naught I naught divided by 2 into T from integration T equal to 0 to 1 time periods, inside of this one 1 minus cos twice omega t and dt. So here integrate 1 E naught I naught divided by 2t. The integration of 1 would be with respect to timing t, and the integration of cos to omega t, it has the value sin to omega t, and divide the coefficient of t, which is twice omega, and taken the integration limit for lower limit is lower, this is lower limit, this is upper limit. After putting upper limit and lower limit, this value becomes E naught I naught divided by 2t. Put here upper limit, here this is upper limit, this is lower limit. First put the upper limit, t minus sine twice omega capital T divided by twice omega, and put the lower limit, minus lower limit, in place of this 0, in place of this also 0. Now from here we also know that omega is equal to twice pi divided by t. Therefore from here omega t is equal to 2 pi. So here it is a term sine twice omega t. Omega t has the value 2 pi. Sine 2 omega t has the value twice omega t has the value. If I multiplied omega t by 2, it becomes 4 pi. It becomes 4 pi. So we know that sine 4 pi has the value 0. Therefore, after taking this value here, E naught I naught divided by 2t, and this into t, and this value becomes 0. So now after cancelling this, I have this value E naught I naught divided by 2. So this is our average power lost, average power dissipated in the purely resistive circuits. So we also write this value in this terms, E naught upon root 2 into I naught upon root 2. I have replaced 2 by root 2 into root 2. E naught upon root 2 becomes E RMS. So this is the E RMS, root mean square voltage, and I naught upon root 2 will be I RMS, root mean square value. Therefore, the average power loss, our average power loss across this purely resistive circuit is E RMS and into I RMS. So this is our value.